Good day everyone, welcome to our chemistry series. Today we'll be discussing Dalton's atomic theory. Dalton's atomic theory. In 1808, John Dalton proposed the atomic theory, which can be summarized as follows. 1. All elements are made up of small indivisible particles called atoms. 2. Atoms can neither be created nor destroyed. 3. Atoms of the same element are alike in every aspect and differs from atoms of all other elements. 4. When atoms combine with other atoms, they do so in simple ratio. 5. All chemical changes result from the combination or separation of atoms. It is important to note that Dalton's atomic theory could not explain electrolysis and other vital phenomena. As a result, there have been some modifications of Dalton's atomic theory. 1. All elements are made up of small indivisible particles called atoms. This statement has been corrected by Rutherford's discovery. According to him, atom is made up of three main subatomic particles called proton, neutron, and electron. Thus, it is not an indivisible solid piece. 2. Atom can neither be created nor destroyed. This statement is still plausible, but only for ordinary chemical reactions. In a nuclear reaction such as fission of uranium-235, the nucleus absorbs a neutron and breaks up into an equal fragment, forming simpler atoms with a large amount of heat being released. 3. Atoms of the same element are alike in every aspect and differ from atoms of all other elements. The discovery of isotopes contradicts this statement. Chlorine, for example, has two isotopes which differ in their neutron content and relative atomic masses, even though they have the same chemical properties. Number 4. Atoms of different elements should combine in simple whole number ratio to form compound. This statement is too useful, but only for inorganic compounds having few atoms per molecule. But for organic compounds such as proteins, fat, starch, it is not plausible. Silicon, which is inorganic, is an exception as well. It forms complex triazosilicates involving large number of atoms. Constituents of the atoms. The three fundamental particles in an atom are proton, electron, and neutron. The protons are positively charged particles having equal mass as the atom of hydrogen, considering carbon-12 standard. The electrons are negatively charged. They are equal in magnitude but opposite in sign to proton. The neutron has no charge. It is electrically neutral and its mass is equal to that of a proton. According to the nuclear theory propounded by Lord Rutherford, the neutron and proton make up the nucleus of the atom. The nucleus is centrally positioned and positively charged. Electrons surround the nucleus in an orbital manner. The arrangement of electrons around the nucleus. Electronic configuration is basically the arrangement of electrons around the nucleus. According to Bohr, electrons revolve around the nucleus in circular paths called orbitals or shells positioned at some distance from the nucleus. The shells are denoted by the letters K, L, M, N, O, P, and Q, which increases from the nucleus. Shell K, nearest to the nucleus, has the lowest energy and contains the least number of electrons, that's 2 electrons. The maximum possible number of electrons in a shell number is n is 2n squared, where n is the shell number. In the innermost shell K, the maximum number of electrons is 2. The second shell L is 8. The third shell M can also hold up to 8 electrons with a maximum of 18 electrons. Electron shell. Now we have an example of how the electrons are positioned around the nucleus in the diagram as shown below, and this is the electronic structure of the atom. Below is a table of the electronic configuration of the first 20 elements. It shows the elements, their atomic number, and their KLM electronic configuration. As you can see, hydrogen has only 1 electron in the K shell, and something like boron has 2 electrons in the K shell and 3 in the L shell. Calcium has 2 in the K shell, 8 in the L shell, 8 in the M shell, and 2 in the N shell. We have some examples we are going to be using to revise this topic we've discussed. The first question says that according to Dalton's atomic theory, matter is made up of A. molecules only, B. atom, C. ion, and D. electron. Now, one of Dalton's atomic theory states that matter is made up of indivisible particles called atoms. So our correct option is B. The next question is from NATEP 2017, and it states that the fundamental particles of an atom are A. Proton, nucleons, and electron. B. Proton, nucleon, and neutron. C. Proton, nucleon, and neutron. D. Proton, neutron, electron. And E. Proton, nucleus, and electron. Now, the fundamental particles of an atom are proton, neutron, and electron. And the correct option is D. We have another example that states that according to Dalton, a chemical compound is formed when A. Atoms are split, B. Atoms combine in fixed ratios, C. Electrons are removed, and D. Nuclei fuse together. One of Dalton's atomic theory states that chemical compounds are formed when atoms combine in fixed ratios. So our correct option here is B. Now we have a theory question that states that state theory of Dalton's atomic theory and state their modification. Now, Dalton atomic theories goes as follows. The first will be stating is it states that atoms are made up of small indivisible particles, and this has been modified because of the discovery of subatomic particles. So atoms are made up of subatomic particles known as electron, proton, and neutron. Number two, Dalton atomic theory states that atom can neither be created nor destroyed, but the discovery of nuclear chemistry disproved this, because during nuclear reactions atom can be created or destroyed. Now, the third atomic theory will be discussing states that atoms of the same element are similar in all ways and differs from atoms of other elements. Now, this has also been modified due to isotopy or the discovery of isotopy, because atoms of the same element sometimes, even though they have the same atomic number of proton and electron, they have different number of neutron, which leads to different mass number. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Fact Chemistry textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of your screen. Thank you.